Am I up? Oh my gosh. So this weekend I did something new. We went to part of the Lab Everyday community. We had our first meetup, sort of a big group meetup. I don't know how many people showed up, probably more than 20, less than 30, I guess. And it was a really fun time. And while I was there, I was trying to stream and it just became chaotic. So I didn't get a recording of my presentation, but I did stream a little bit of the event as a whole. And I screwed up my streaming software layout. So this morning I had to sort of rebuild everything, and I have audio muted. I have some video that's not showing up. I had to rebuild the intro. It's been a mess this morning. Anyhow, today I definitely wanted to get some labbing in. I had a very busy weekend, being I call it a holiday weekend. Even though Thanksgiving falls on Thursday for most people, I do celebrate Thanksgiving on Thursday. My family is split, so we also celebrate Thanksgiving on Saturday. And so that was yesterday, and we had a big Thanksgiving, and it was great, and we had a good time. But it definitely throws off your study schedule. So for all of you out there who are working towards certifications and trying to build up a good study schedule, it's definitely tough around the holidays. But even on days that you're just like today, I'm exhausted. I'm absolutely exhausted. Yesterday was a huge day. I was up since 5 in the morning, preparing a turkey and everything else. So today, all I want to do is just lay on the couch and watch TV. But I'm forcing myself to get some lab time in, and so that's what I'm going to do. So thank you all for spending some time with me this Sunday morning. I don't think I'm going to do one of the pre-canned labs, like one of the INE labs or one of the Cisco 360 labs. Not today. It's a little bit too late to start one of those. It's 10:30 in the morning my time. Normally I like to get started with those around 8 because they tend to go pretty long, about 6 hours, 5 or 6 hours long. So today I'm just going to kind of work on a topology that I did this weekend as part of the Lab Everyday meetup. Which was a DMVPN topology, and I'm just going to kind of work through it a little bit and try to explain things as I go. And I want to work on some protocol summarization. So I want to do protocol or routing summaries in RIP and EIGRP and OSPF and BGP if we can get to it. Also, I want to try and do some prefix filtering. That should be pretty fun. Because there's lots and lots of different ways to filter prefixes. And if it's not something you do all the time, there are just so many different ways you have to be sharp on them. And I definitely want to be sharp on them before I get ready for my lab exam. So I also wanted to talk about, let's see if we can bring camera up here. Also, Duan launched the labeveryday.com website. This weekend at our event, so that was a lot of fun. Definitely, if you want to be part of the community, we're just getting started. Duan's already published, I think, a couple of small blog posts here. The forum has a couple of people in it, and so we want to see this grow and become a great place for the community to be able to come together. Aside from when people are streaming, Duan streams a lot, and everyone likes to jump online and be part of the conversation. And here's where you can be part of the conversation even when people aren't online. So definitely check it out. I myself, I need to get logged in here and registered. So definitely be part of the community if you can. It's great to be around people who have similar goals and a similar support. So that's what the community is all about. Also, if there are any opportunities for giveaways or things like that, that'll be a great opportunity to be, maybe we'll have some giveaways and be able to post some on there. I know at our event on Friday night, we gave away 2 NetSim 12 products from Boson. So if I do Boson NetSim 12, they have a couple of different versions here. So they have it for CCENT and they have it for CCNA. So Boson was kind enough to give us 2 free products to give away of their NetSim 12 product, and so we gave that away to 2 people who are studying for CCNA. So that's going to be really cool, and it's really going to enhance their practicing for labs and learning and grasping the technologies and getting ready for the certification exam. So very, very cool. And thank you, Boson, for doing that. And I hope everyone finds it enjoyable. I used the Boson practice exams for my CCIE. Practice exam, CCIE. For the route and switch certification, which was this product, the Boson software XSIM Max 400/100 for CCIE route switch written. I use this. It is a great platform. It's a questionnaire type platform, and it's got all the drag and drops. So it was a great way for me to take some of the practice tests and then use the questions that I got wrong as topics to study for. And so I would go and do deep dives. Also, Boson, I think, has one of the best and comprehensive explanations for some of the questions and some of the answers there. So it was really awesome and very helpful to be able to gauge just how much you need to know. So thank you, Boson, for sponsoring us for the event and letting us have some products to give away. It has certainly helped me, and I'm sure it will help you. Looks like there's a sale here, probably Black Friday sale or Cyber Monday sale going on. So if this is something you're interested in, definitely grab it while it's on sale. All right, so I'm going to dive into some labs today. I see we got a couple of people on stream with us today. So this is going to be the topology that I had from our event on Friday, the Lab Everyday Meetup, that I did a DMVPN examples on. And I kind of don't know what state I left it in on Friday. It was great to have everybody, but it was sort of very chaotic in the sense of it probably wasn't the best classroom style setting. So I definitely look forward to doing future events in probably a more classroom style setting, maybe with a whiteboard or a projector and an opportunity to have everyone lab along. We didn't have that this time, but I think it was great and helpful to be able to give a couple of demonstrations and opportunities to network with each other. I think that was really the most beneficial aspect of having a community event like that is the human networking aspect, right? The ability to meet other people who may be at the same pace as you, studying from the same materials, working for the same certifications. You can compare notes, what kind of study materials work, what kind of study materials don't. And I think that's really like the most important part of a community event like that is the human networking aspect. It's not necessarily the presentations or the materials that we have to offer, but rather it's meeting your peers. At least that's what I find the most valuable, is definitely meeting peers and meeting other people who are doing the same things as you. It's inspirational, and you get to find out what works and what doesn't, and where everybody is. You get to find out how much time people are devoting to studying, and just get to hear others' opinions. So let's take a look here. Show IP route. I think we did DMVPN phase 1 RIP protocol. Let's see if we have a default route here. Default route. We'll do router 3 and a default route. I'm just checking for that default route there and seeing that the other prefixes are suppressed. Okay. Let's see if, I don't think we can add anything. Hang on, do show run interface tunnel 1 2 3 4. I think I need to add encryption to this, but I want to get in here and see if I can add anything else. No, okay. We need to add encryption, and that's one of the beauties about the DMVPN is when you go, hey Land Tamer, great to see you. Nice to hear your insights on Meetup. Any new CCIE route switch candidates? Not out of our event, I don't think. There were 2 women there who were CCIEs already, and so it was really cool to be able to meet them and inspirational for me, you know, because I'm trying to achieve CCIE. So it was really cool to meet them, and it was Erica Cooper, and I can't for the life of me remember the other lady's name. But it was very awesome, and you know, I hope to join the ranks as well. I think most people at the event were CCNA and CCNP focused. I think there was one gentleman, at least I talked to, who is looking to do the CCIE written soon. Hey, Network Bro, good to see you. Good to see you. Network Bro, I think you joined us on stream on Friday night, did you not? I thought I saw your name pop up in the chat. But I think there was only maybe one other person there who is getting ready to study for the CCIE written. So, you know, I'm able to try and give a little bit of advice on what it took for me to pull through. And it was tough, you know, and I definitely shared my story of the other night, or the other day rather, I think earlier in the week, when I posted that I had failed the CCNA exam. A friend of mine at work is studying for CCNA certification, and so he was taking a CCNA prep exam, and I just was like, you know, what the hell, maybe I'll take the exam too, and I took it and I failed it. I just barely failed it, but I did fail it, and it was very humbling and rather embarrassing because, you know, people sometimes look at me as if I already have my CCIE and that I know everything about networking, and I certainly don't. I'm always learning, but to fail the CCNA was a little embarrassing. But I thought that it was also a little bit inspirational to see that I failed the CCNA, to show people that, you know, if you have recently gotten your CCNA, it is a hard exam and it is a real accomplishment, and everyone should be proud. Getting your CCNA is not some small feat. It is a big deal, you know, so definitely work hard, do it, and celebrate. It's hard, even for someone who's already passed the CCIE written exam at least. CCNA was definitely hard. I wish the version of Boson had PPPoE. The version I have doesn't have it. Huh. I'm trying to wonder, let's see, the Land Tamer and I are both using Boson for the written. I'm trying to think. I don't know if there was PPPoE on it, and I don't know if there was PPPoE. There was some PPPoE on it because I remember it is like, what is the handshake for PPPoE? And I remember it's like Pado, Paddy, Padar, Pade. Right? You guys know what I'm talking about? Let's see if I can just pull it up on a notepad. I'll bring it over here. This is what I remember from the written. It was Paddy, Pado, Padar, Pad-A, which is initialization, offer, reply or response, and acknowledge, right? Yeah. Oh, Pad-S? Is it Pad-S? Landtamer's probably right. He's always right about these memorization drills. I thought it was Pad-A. We could do Pad-S. So, and actually, I had never done PPPoE before I went into Narbix boot camp. But when I was at Narbix boot camp, he drilled into PPPoE quite a lot, and that was a hard topic for me to understand because of the way you configure it. You know, you do like a virtual template on the PPPoE server, and on the client you do a dialer interface, and then you have to reference those in the physical interface, and there's a BBA group, and it's craziness. But anyhow, I'm glad you could see us on stream a little bit. Yeah, I mean, I still struggle with it. Anytime I see PPPoE in one of the labs that I do, it always is sort of a speed bump that slows me down. Same thing through. Same thing through. Yeah, I'm struggling with that same thing through. Luckily, it's only on the client side on the NP. Oh, okay. I didn't know that. I don't think I remember any PPPoE on my CCNP. And even though I know it's an old technology, I just don't remember it being on my CCNP. I did my CCNP 3 years ago, almost exactly 3 years ago. I think last December. No, not last December. It was December 3 years ago. So almost exactly 3 years ago, I did my NP. Anyhow, since I have you guys joining me on stream, how's the audio? Because I don't know if you guys saw me in the beginning, but I completely trashed my my profile here on OBS, and so my audio was all screwed up, my intro was all screwed up, the video switching was all screwed up, and I had to kind of rebuild it, and I don't remember where my audio levels were. So am I too low? Am I too loud? Audio is great. Very cool. Awesome. All right. Well, perfect. Sounds good. Awesome. Oh, you got headphones. Yeah, I don't have anything today. I'm exhausted. I'm unprepared. I'm still in my pajamas. But I guess without further ado, what I'm going to do is go ahead and put encryption on this DMVPN network. And since I have this notepad open, I guess I'll just use it. And let's see if I can recall from memory all of the steps to put encryption on a DMVPN tunnel. So one of the beauties about DMVPN, and I hope that I gave a glimpse of this on my presentation on Friday. And again, for anyone who's out there watching, sorry I could not stream my own presentation. It was just chaotic, and I didn't have the stream set up ahead of time, and that's just how it was. It was a great event, so I didn't mind not streaming, but we had a great audience there. One of the things that I tried to give an example of at the event was that DMVPN is so beautiful because when you have to configure the spokes, you only ever have to change one thing, which is the tunnel IP address. And so you just change that, copy and paste it through. And that's one of the, again, another beauty about doing the encryption for DMVPN is because you just have to copy and paste the same thing on all of them, and then it just works. So, all right. I don't even fully remember what goes into it, so I'm just going to try and pull it from memory. ISACamp policy 12 or 10, we can start off with that. We're going to do authentication, pre-share. I'm going to leave the other elements as default. Oh man, this is not working for me. Crypto, ISACamp, policy 10, crypto, ISACamp. Oh man, I think I need to use my context sensitive help. I have to get in and use a question mark. ISACamp key, tunnel key, what is it? Authentication, ISACamp, authentication, crypto, ISACamp. I already did policy and a number, so crypto. What is it? Oh, crypto key. No, crypto key. I'm losing my mind here. Crypto ISACamp key. Okay. Then the password. Okay, so we can just do Cisco. Okay. Yes, that's what I'm missing. All right, see how long it's been since I've done it? And we'll give a wildcard address because we are the hub. Subnet mask, we can just hit enter there. Let me grab that. Crypto ISACamp key, Cisco address. Okay. Next is crypto, IPsec, transform set, and we'll just go with the my set, what's like it is in most examples. Yeah, chat at the Land Tamer. There is authentication. Oh, authentication in the MP. Chap and Pat, but for some reason I can't find PPPoE client, even though the website says it has it. Yeah, I'm telling you, I don't remember it being in my test. I do remember Chap and Pap, and that was for PPP, point-to-point protocol, which I think they used on the serial links in my CCNP. So they had us do like PPPoE, not PPPoE, point-to-point protocol on the serial links, and had us implement Pap and Chap. But it wasn't PPPoE, which was a little different. my set, and then I forget the transform set format. So crypto IPsec transform set, we'll call it my set. I'm going to do ESP AES, and oh, you know what, Land Tamer, let me, if you're out there, let me ask you a question. I don't know if you're watching this this stream here. So if I go back here, I guess I was just sort of always confused on you know, the values. So like I wonder what it puts here by default if I don't specify a number. So here I put like 192, and then we'll grab one of these, and I think we can just go with that. Hang on, 192. I just didn't know if you had a cheat sheet or something on like what these values mean and how to remember them. I don't know if you had like a mnemonic or a way to do that, because the list can grow and grow. And it's been a while since I've done this, so oh, I actually didn't mean to do that. Nope, I want to do mode transport. All right, then here I want to do 192 is the length of bits for AES. I know I always get confused when it has like the ESP AES 256 HMAC. You know, like for here it says SHA HMAC, and some of them are, I think they have numbers in them as well. I just get confused when I look at this section of command line, just because it just seems, just in my mind, it just seems like so many letters and numbers that have, I know they have meaning, but I can't distinguish between them. It just seems like alphabet soup. I don't have a mnemonic for memorizing IPsec config though. When I start prepping for the lab, I'll just be repetition over and over, I think. Yeah, I mean, that's what I did previously, and it's been so long, that's why I'm struggling here. But I thought I'd ask, because I know you have a lot of stuff on your cheat sheets that are really helpful. All right, so this is going to be crypto, and again, I forget what the format of this is. Crypto IPsec, I think it's profile name. I like to call it DMVPN. Let me grab this. Enter, and then I do set, transform set. We called it my set. Well, we didn't call it yet. I don't think I put it in. Proposal tag. Set transform set. I think that's it. Okay, so we have our policy, which we're going to leave default values for encryption and hashing. We're just going to say authentication pre-share. Here is our pre-share key, and we're going to allow that from any peer. Here's our transform set, mode transport. And here's our profile. Next thing we want to do is interface tunnel. Since I already have all the tunnels named the same, we're going to do tunnel protection I think it's IPsec, profile, and the profile name. And I think that's it. So let's see. I'm going to paste it in sort of small chunks just so I can catch any errors. Okay. I'll paste these in. Okay, and that's one of the things about the encryption in DMVPN is you can paste in these 4 elements and it doesn't do anything to the running config. It doesn't do anything to the router because it's not applied to anything. So none of your tunnels will bounce. None of nothing else will go up and down. It's really just a config that's sitting in the running config and doesn't do anything till you activate it on an interface. So it's a good way to go ahead and sort of pre-stage all this ahead of time. And when I'm doing these encryption configs, I don't know if everyone else does it this way, but I sort of separate it into these 4 manageable parts. Let's see if I can widen this out a bit. I think if I take it all the way across, does it fit? Almost. So I always do this first part here. I do the second part, the third part, and the fourth part. And that's just how I sort of remember it as my order of operations in the 4 separate parts. I know when I was, and I'm not an encryption expert, but when I was studying on how to configure this and trying to remember what are the steps, that's how I mentally sort of broke it down into the 4 different parts so I could always remember what was going on. All right, so I think that worked pretty well. Let me apply it to this interface. And this is going to be on the hub, so router 1. And we see ISAKMP turned on. We should see the tunnels fall over, right? I don't know if we'll see that here. But I think we're in a good position where I can just go ahead and paste this around. And again, this is one of the reasons why I love DMVPN so much. Let's get into config mode, config mode, config mode. All right, that looks good. So if I do here, show crypto, ISAKMP SA. I see no state. Okay. That's main mode. MM is main mode, no state. Okay, like we see here, protocol 47 is GRE. Received a packet, not an IPsec packet. So what that means is on router 1, on the tunnel interface, I guess the physical interface, it received a packet with protocol 47, which is straight up GRE, not IPsec, and it knows it. And it says who's it from, so that's router 2. So we will see that change. Although even when you apply IPsec to the DMVPN, it is still a protocol 47 packet. It's still GRE. Only the payload is encrypted. But this is a good indication right here. You're going to see this error message when you have encryption configured on one side and not the other. That's what this is saying. Let's see, Lane Tamer, I did a keyword search through the whole database, custom courseware, and standard, no dice. I may just practice on packet tracer and make an assessment lab. Yeah, you can you can follow the Cisco doc examples if you need a sample lab to try, although sometimes their examples are extreme. But yeah, I found a config doc from Cisco, and it's a bit over the top. Yeah, I think I found that the PPPoE, if that's what you're still talking about, the PPPoE configuration, the documentation can be very wide because there's a lot of different knobs to turn there. But for a basic implementation, there's not that much. I'm looking around for my book. Let me see. Volume 2. In the CCIE Routing and Switching Official Cert Guide, I forget if it's volume 1 or volume 2. There's a PPPoE section, which is very small, actually. It's only like 3 or 4 pages, and most of it is CLI output. But it's a very simple breakdown of PPPoE, and that's what I kind of use as my sort of mental template as my baseline for configuring PPPoE. I hope they don't have you doing too much at the CCNP level, because I don't know. I hope it's just basics for you. Just keep it simple. All right, so let me grab this this whole config here, and I should be able to paste it all the way around, and everything should work. Let's see. All right, that's router 2. ISACamp is on. Router 3, router 4. Let's see. ISACamp on, ISACamp on. All right. So now let's go up arrow. We're going to show crypto ISACamp security associations. All right, we have some stuff coming up. Here we are. This is quick mode, idle. I still don't have a firm understanding of all the different states. I know we have main mode and quick mode. Main mode, I think, takes 6 packets to form an IPsec security association, and quick mode, I think, takes 3? Or wait a second, is that aggressive? Aggressive. All right, and then let's do show crypto. We'll do show crypto IPsec SA. And here it's coming from our tunnel interface, our local address, our remote address, protocol 47, right? So that's GRE, port 500, typically UDP for port 500. Origin is ACL. It'll say that even though I didn't specify an ACL, I think it sort of generates that on its own in the background. I don't know if there's ever a way to actually see that, but 4 packet encapsulations and decapsulations. There's really a lot of output out here. I don't have it all broken down and have it all memorized. I'm just trying to get familiar with it, but okay, so right now we have full encryption all the way around. So actually what I want to do is I'm going to save this and put it in that Dropbox folder. Let's see if I can do. I'm going to say tunnel encryption for all configs. I think that'll work for all of them. For all configs and all routers. Tunnel encryption for all configs and all routers. Put that in there. So that'll kind of go along with the configs that I've shared from the meetup on Friday. So you should be able to just copy them. If anyone's following along, you can just copy and paste this and apply it to all of your routers, and you should have a working encrypted transport DMVPN. All right, so I am running RIP here on these routers. I'm trying to think. Trying to think if maybe I should do some like EIGRP. In fact, I will. I'm going to do some EIGRP, and I'm going to do it static configuration EIGRP, and I think I need to work on some IPv6 too. There's just so many topics to cover. It's really hard to get them all. So for here, I'm going to do no router RIP. No router RIP. No router RIP and router 3. Now I think that will also take off the summary off the physical interface, or the tunnel interface rather. Do show run interface tunnel 123.4. Yeah, it removed the RIP summary. All right, I think these guys do show run interface tunnel 123.4. These have a tunnel destination. Which means they're point to point. So I think what I'm going to do is change these to multi-point GRE. So I think I can just make a little script here. Interface tunnel 123.4, no tunnel destination 168 1.1. Let me verify that's right. No tunnel destination, and instead let's change it to tunnel mode GRE multi. That should enable us to build some dynamic spoke-to-spoke tunnels. So let's paste that in. Okay, we see the tunnel went down, tunnel up. All right, next if we do a protocol, in fact, let me just check because I don't want to get caught by any surprises. Here's our IP address, no IP redirects. We're mapping multicast traffic. We got our network ID. In fact, we can throw that multicast map right on the end of here. Source mode key protection, we're good. Okay, so I want to do EIGRP. I want to do EIGRP, and I want to do it with unicast traffic. And I guess I'll do it named mode. Or maybe I'll try to do both. Router EIGRP 1, 2, 3, 4. No auto summary. Let's do neighbor 10.1 123.2 and tunnel 1, 2, 3, 4. All right, so we should be able to just enter up arrow 3, up arrow, do 4. So those should be our 3 spokes, 2, 3, and 4 of the spokes. I'm also going to do passive interface default. Just because last time I did a lab, I got confused on whether you needed to put your unicast interfaces in a passive mode or not, because I think in like RIP you have to, and in EIGRP you don't, or something. I get it confused sometimes. One of the hardest things for me is not studying and learning new material, but rather keeping the old material straight. That's really one of the hardest parts of I think the whole process, the whole journey here. So what I'm going to do is configure this as well on the spokes, and then we'll see if we form an adjacency. And if we don't, then I know that this passive interface default is what's breaking it. So router EIGRP 1, 2, 3, 4. No auto. This would be a perfect opportunity. Router EIGRP to no auto and neighbor 10, 1, 1, 2, 3, 1. Tunnel 1, 2, 3, 4. Oh, and also passive interface default. Save us a little time if we can sort of script it out. One of the interesting things that we were discussing after the event, or towards the wrap up of the event on Friday, was someone was asking me for some clarification on, you know, what a hub and spoke topology looks like, and sort of how it operates. And one of the very interesting things about DMVPN and a hub and spoke topology in general is when you're dealing with routing protocols, your data plane traffic in like a phase 3 DMVPN can go from spoke to spoke. However, your control plane traffic, no matter what phase you're in, will always go from spoke to hub. You know, you'll always be telling the hub about the prefixes that belong to your router. You don't ever tell any of the other spokes that. And it's by way of the hub that you learn about the networks that are attached to other spokes, and allows you to build that direct spoke to spoke tunnel. But the control plane traffic never goes from spoke to spoke. I always thought that was very interesting. So I don't see an adjacency. Show IP. Let's do show. So if we were going to troubleshoot this, let's say router 4 and router 1. I just want to make sure I have 192.168.1.1 reachability there. All right, so I wanted to, here I am trying to troubleshoot EIGRP. So show IP EIGRP interfaces, and we don't have any interfaces. Show IP protocols. Should say EIGRP, and we don't have any neighbors, and I don't see it turned on for any interfaces. Okay, so let's get into interface tunnel 1 2 3 4 and do, or excuse me, router EIGRP 1 2 3 4 and do no passive interface tunnel 1 2 3 4. Now if I do show IP EIGRP interfaces, I would expect to see an interface in there. Show IP protocols. Have I screwed something up? Passive interface default. No passive on the tunnel. I would have expected to see something here. You should see that show IP EIGRP. Tunnel 1 2 3 4. Yeah, interfaces, detail. I would have expected to see one there. I wonder if it's because I have unicast neighbors configured there, or configured out that interface. It doesn't make sense. So I tell you what, let me take off passive on router 4, router EIGRP 1 2 3 4, and router 4 and router 1 should form an adjacency. So no passive tunnel 1 2 3 4. I don't see the interface there. Show IP EIGRP interfaces. I don't see it there. Show IP EIGRP neighbors. Nothing. Show IP EIGRP. Yeah, well, we shouldn't have a neighbor if we don't have interfaces. So what's going on here? Show IP protocol. Let's take a look at our tunnel config. Show, oh, you know what? Hang on. Show IP interface brief. Tunnel is up. Show DMVPN. I think I might know. Do show DMVPN. Interface tunnel 1234. IP NHRP registration. Timeout, number of seconds, 5 seconds. This is very strange. So I guess what I'm going to do is I'm going to do a hard shut on the interfaces. Let's see what happens. Interface tunnel 1234. I think I'm in it. And do a shutdown. ICCamp is off. Protocol's down, down. All right, let's bring up the hub. No shut. All right, ICCamp on. Protocol on tunnel is up. Change state to up. This was not intended to be a troubleshooting example, but I guess I'm kind of glad that it is. Do show DMVPN. Well, I still can't figure out why I don't have the interface configured. Okay, we got our multicast traffic set, got our next top server set. I don't see the problem. Let's see if I can turn on some debugs. Show run interface tunnel 1234. Let's just want to verify the configuration. Map multicast dynamic. I'm wondering, do I need to put in like map statements? Oh, okay. You know, I see what the problem is now, and I can't believe I wasted this much time. looking at it, or rather not seeing it. I never activated the interface with a network statement under EIGRP. Oh my gosh. Oh my gosh. Network 10, 1, 1, 2, 3, 0. No, that's going to be... now you'll see it. Show IP, EIGRP, interfaces. Here we go. Unbelievable. Router, EIGRP. That's one of those things that in my mind I was just, you know, picturing the behavior like BGP, you know, where you can define a neighbor and you don't have to activate an interface. You don't even have to advertise anything to a BGP neighbor, but you can form a peer relationship. And well, that wasn't the case here. So here we have our adjacency up on both sides. So I guess we can turn off the debugging you all. I think I'll leave it on here on the hub just to see. All right, but I'm not advertising anything else. So let's see what we have here. Show IP interface brief. 10444, okay. Router EIGRP 1234. Let's do network 10440 and advertise that up. Okay. Do advertise out tunnel. I don't typically look at debugs too often. You know, I certainly should, probably far more than I do. But I'm always in a race to get configuration done and don't have the time normally to do the debugs. But it is extremely valuable. I started off my studies doing debugs a long time ago and have fallen out of practice with that. Okay, so all right, got my neighbor in there. I got everything ready. All right, copy, paste. So we should see an adjacency come up, I do believe. I think we can also paste it in here. Router 2. I forgot the EIGRP is quick, man. Real quick. Boom. All right, so now each one of these needs to advertise its own prefix 10220. Got it. Config T, router EIGRP 1234, and network 10323. Okay. So now it's going to advertise out the tunnel 1234. I see it has this statement, what, 3 times, 4 times. I think it's because it replicates it out to each tunnel. It says do advertise out. But I think there should be a split horizon issue in here, right? Show IP route. Yeah, so I only see my own interfaces, the common tunnel interface subnet, and then the physical interface, right? So I'm not learning the other spokes networks, which is exactly what I would expect. And it should be the same all the way around the board. Yeah. But here on router 1, show IP route, we should see everybody's. We should see the local, which is 1111, and then we should see the 220, 330, and 440 respective of each of the spoke networks. Let's see, you didn't have to put those wildcard masks in the network statement, did you? You don't. If you don't put the wildcard mask, first of all, EIGRP is a little bit magical. So I tell you what I'll do. Let me get in here and show you a couple of things since you asked. You don't have to put the wildcard mask. If you don't, it will use the classful mask. Okay. Also, EIGRP doesn't have to use a wildcard mask. You can put a subnet mask in and it'll automatically convert it. I absolutely love this. So on router 1, let's use router 1's network because we're not advertising router 1's network down to any router yet. Let's do network 10. If I just hit the 10 like that, or if I just hit 10.110 and hit enter, and then if we do show run all section router EIGRP, you see here's that network statement I just put in. And because I'm not specifying a wildcard mask or a subnet mask, it's defaulting to a classful 10 network, even though, look at my command I put in. The command I put was network 10.110, and what EIGRP did, or what the router did, is it automatically converted that to classful because I did not specify a wildcard mask. So in the case of a 10 network, the RFC 1918 10 address space, /8 is correct. If I was doing something in the 172.16 through 172.31, it would have done it, I guess, or it would have been classful, right? Not just the RFC 1918 space. Excuse me, I'm speaking incorrectly. Something numerically lower than 128 is going to be a /8. Something between 128 and up is going to be a /16, right? And then something more than that is going to be /24. I forget where it is. 192? No, 172. So yeah, so that changed. So what I will do is I'm going to put it in again. So I'm going to do no network. Just get rid of that statement. We're going to see EIGRP withdraw that from the remote routers. And so let's put this in network 10.110, because this is the network that we want to specify. But instead of a wildcard mask, I'm going to put a subnet mask in. And if I hit enter, it's going to advertise it. And then I want to show you what do show run section router EIGRP, what that looks like. See, it converted that statement into a wildcard mask, even though what I actually included was a subnet mask. So EIGRP will automatically convert your subnet masks if you accidentally put it in a subnet mask to a wildcard mask. But if you do not include a mask, it will use the classful of your network address. Yeah. So right now, at this point, all of the spokes should have router 1's network. Here it is. But none of the spokes know of the other spokes' networks, which is to be expected at this point. And that's because of split horizon, right? Split horizon here on the hub. And to turn that off, we need to do it on the interface. So we're going to do no IP, split horizon, I think EIGRP, and our autonomous system number. Our neighbor should bounce, and we should see a whole bunch of new prefixes. So now we have all the remote prefixes. But all of the remote prefixes, here is router 2. Router 2 sees router 3's prefixes and router 4's prefixes. it still thinks that the best path is through router 1. Router 1 being the hub. But it's not true. There is actually a better path, right? Router 2 should be able to dynamically create a tunnel to router 3 or router 4 if they're going from their local subnet to the remote local subnet. They shouldn't have to go through the hub. So let's do ping 10, and we'll go to the 3s, router 3, and we'll source from 10.2.2.1. We send those pings. Maybe I should have done a trace route. And so that's going through router 1. And again, it's going through router 1. And if we trace route a whole bunch of times, it'll still go through router 1. And that's because from router 2's perspective, show IP route, it thinks that the next hop to get to this network is router 1. And that's because of the distance vector way of sending prefixes. You're always sending the prefix with yourself as the next hop. So again, to get around that, we're going to do no IP, next hop self, EIGRP, and 1, 2, 3, 4. As soon as you paste that in, it's going to resync all of the prefixes. And when we check the routing table down on router 2 and the rest of the spokes, we should see the real next hop for those spokes. Show IP interface, show IP route. And now you see on router 2, which I'm on, our next hop to reach router 3's network is via router 3. And our next hop to reach router 4's network is the tunnel interface of router 4. So now our prefix, let me see if I can get my pen. And this is something that I was trying to say earlier. The discussion that I was having at the Meetup event, which is right now we have router 2, router 3, router 4. We have an internet cloud, and we have router 1. We're all connected to a common. And then, of course, what we have here is we're all in the DMVPN, which is the logical subnet that our tunnel interfaces are part of. Router 2 is exchanging prefixes with router 1. Router 3 is exchanging prefixes with router 1. Router 4 is exchanging prefixes with router 1. And because we turned off split horizon and next hop self, now router 2, when it wants to see router 4's LAN network, which I'm making these upside down T's, when router 2 wants to send a packet to router 4's subnet, it knows that the next hop is the tunnel interface of router 4. And that's because router 1 is no longer doing the next hop self. But what's going to happen here, let me close that. What's going to happen here if we do show IP NHRP, even though the next hop for router 3's network is router 3's tunnel interface, router 2 doesn't actually know where that is. And we know it doesn't know that when we do show IP NHRP. It only knows router 1's tunnel interface is mapped to this physical interface. So what router 2 is going to do is it's going to send a resolution packet, NHRP resolution, to the hub, which is router 1, and says, hey, I'm trying to reach router 3 subnet. Do you have a resolution, non-broadcast multi-access address for router 3? And so if we do a ping 10.331, source 10.2.2.1, and if I do a pcap, I think I can capture right here on router 1. We should be able to see this in Wireshark. Oh, of course it's all going to be encrypted. Oh boy. it is all going to be encrypted. So we will not be able to see that. But I wonder if we turn on some debugs. Or maybe I take off encryption. We can do that too. To make this more challenging for myself, I'm going to try and find the debugs so we can actually see that. I don't know what they're going to be, so let's just fumble our way through it. Wireshark is not going to yield us anything because all of our payloads are encrypted. All right, but I'm going to send this ping. I'm going to send, let's do debug IP NHRP. All right, debug NHRP. Send registration reply. Okay, registration reply. We're going to be looking for resolution. And this is a lot of output. And let me try and find the correct debug. Show IP NHRP. Excuse me, show NHRP. Packet? I'm scared. Oh, crap. It's a lot. All right, registration reply, registration reply. Okay, let's see what happens. I'm scared router 1 is going to blow up. Overwhelmed with logs. All right, we're going to ping from router 2's LAN interface to router 3's LAN interface. We should see a resolution packet go between router 2 and router 1. And then the ping should be successful. Router 1 is going to tell router 2 how to get to router 3, and then they'll start communicating directly. So if we do debug, I don't want everything to be blown up. Debug NHRP packet. What if I just say screw it? All right, ready? Okay, so I just did a quick UL. Here we go. I'm trying to see. Okay. I'm scrolling up on router 1. Here we go. NHRP received a resolution request via the tunnel interface. It should say sourced from, uh-oh, I did not want to paste that in. I lost my place. Sourced from router 2. The source protocol is our tunnel interface. And the destination is for router 3's tunnel interface. And forwarding the resolution request via the tunnel. So source from router 1, tunnel interface, destination for router 3's tunnel interface. And if we scroll down a little bit, the source was from the non-broadcast multi-access here. Source protocol was 2. Let's see, this must be router auth source stable net. Okay, protocol 3. This is what I expect to see. And then receive the resolution request. We should see it come back the other way, I do believe. From router 3 is looking for router 2. And if I scroll further, forwarding the resolution request from router 3 to 2. Right, that was it. And I think we saw the same here when we did the debug. We scroll up just a little bit. Received resolution request. All right, sending a resolution request. So this is router 3 trying to find router 2. Sending a resolution request. Received a resolution request. So it received one coming from router 2 to router 3. Receive a resolution reply. So it got the reply. And that should tell it that router 2's tunnel interface can be found at this public interface or non-broadcast multi-access NBMA. And it's sending a resolution reply for itself, I believe, right? Which is saying, hey, my tunnel interface is 10.1.1.2.3, and my physical interface is 192.168.1.3. That's pretty cool. It's really a lot of debug to sort of decipher, but that's what's going on here. So now when we do the trace route, and we want to go to router 3's network, source from router 2, it should just be one hop, and that's what we're seeing. It's going directly from router 2 to router 3 and no longer has to traverse router 1. So even though the data plane traffic what I'm going to do here is I'll do blue. So right now, router 2 is sending traffic to router 3, and router 3 can send traffic back to router 2 over a direct spoke-to-spoke tunnel. But the control plane traffic, the EIGRP traffic between each spoke is still going to router 1. So the green is going to be EIGRP, and this is going to be your data plane. So even in a phase 3, or I guess we can consider this phase 2, DMVPN, no matter what, your spoke's control plane is still between the hub, while you can forward traffic from spoke to spoke. Okay. Getting a little tired. I told you guys I had a busy weekend. Super, super busy weekend. Thanksgiving 2.0 was yesterday. It was a lot of fun. It's one of the first times I've hosted my family at my house. Normally, when we have a Thanksgiving between my family, we go to my family's house. And first time we did it here at my house, it was a lot of fun. Everything worked out pretty good, but I am exhausted. All right. So I guess what I want to do next is, I wonder if I can do some like prefix filtering. Maybe throw a bunch of loopbacks on the spoke routers and see if we can filter between them. I think that could be good. What else? I think maybe I can do IPv6, which is definitely something I need to work on. I always, anytime I hit the IPv6 section in a lab, it slows me down a bit. I swear I have a mouse here. This mouse is not working. Okay. Awesome. So let's IPv6. I don't even really have an IP schema um, configured for IPv6, but we can configure IPv6 in parallel with IPv4 because they always say that, like, IPv4 and IPv6 are like ships in the night. They can coexist on the same media, um, without affecting each other. I wonder how many people out there who are on stream today deal with IPv6 in their networks. You can let me know in the chat. I don't. I don't deal with IPv6 in my networks at all. So my only experience and my only drive for wanting to do IPv6 is for the lab. Oh yeah, the land tamer. The land tamer has done something wild that I don't know if anyone else on stream knows, that he converted his home network to IPv6 just to get the experience of doing so, and I think that is so incredibly awesome. I can't believe it. It is something I wish I could do, but I don't know if I have the time to troubleshoot it. I have so many things that are all online, right? All online on my network, that I think most things, probably all things, support IPv6. But if something doesn't work and then I got to hear about it from my kids or my wife or something, or I just don't know if I have the energy and the time to troubleshoot it. You know what, that would be a good test. So I think maybe one day after the CCIE is completed, to migrate my house from IPv4 to IPv6 and do it like an overnight cutover to convert everything from IPv4 to IPv6 and just give myself a little window to troubleshoot, like a regular cutover would be, and to make sure that everything works before anyone notices anything different. I think that would be pretty cool. But I've heard that like some cell phones, and I don't know if it's a brand or a carrier or whatever. I guess it wouldn't be carrier, but cell phones that try to join Wi-Fi with an IPv6 network, that it doesn't work all the time. Man, I've been studying this since like 2014. I have yet to run into a network completely IPv6, not even dual stack. Dual stack it, man. Then you cut over service by service. That's an excellent point, Land Tamer. Excellent point. They've been saying we ran out of IPv4 addresses since like 2011. They have run out of IPv4 addresses. They ran out of addresses. So let me clarify that statement, okay? I really do want to clarify that statement, because they ran out of IPv4 addresses to sell, and they ran out of IPv4 addresses to assign to people, companies, and organizations and agencies, okay, and countries. But that doesn't mean they ran out, okay? There are large portions, okay, maybe not huge portions, but there are, if you look at the global IPv4 usage, there are large portions of IPv4 space that go unused a lot. Like whole /16s not being used. I realize that's only like 65,000 IP addresses, but I mean, come on, that's 65,000 IP addresses. And I'm not talking about like 1/16 that doesn't get used. There are like tons and tons and tons of /16s and /24s that just go completely unused across the internet. So they did run out. However, I always thought that these companies and like some universities have like /16s assigned to them, and they only use, a /24 of their space. And, there could be a real financial gain to sell that back into the public domain, or auction it off or something. I thought would be very cool. let's see, in some cases you'll get a performance bump out of IPv6. I've heard that actually. I've heard that, and it's just a rumor. I have no way to back it up. I mean, maybe it's not a rumor. Someone else did the research, but I have no way of verifying personally. I heard that people, gamers try to run IPv6 because there's no NAT involved in IPv6. And so you're running at a slight performance increase, like at your router, for a little reduced latency and stuff like that. So I heard that gamers strive for IPv6 connections because it might actually give them that like millisecond advantage. And I guess if you're playing competitively, right? I'm not talking about someone who just gets on Fortnite for a little bit. People who make money playing games try to get every advantage you can. Some of the bogon ranges can be reallocated. Absolutely. I mean, here's what I say. Look, the loopback address space, the 127 address space, that is an entire /8. Okay, your loopback address on a workstation or a Mac or Linux or anything else is going to be 127.0.0.1. Why not allocate the other 2 octets? I mean, you know, leave 127.0.0/24, right, as no man's land for IP address, and let all of your loopbacks fall into that /24 space, and reallocate the rest of the /8. That's a ton of IP addresses, literally unusable by almost every device out there. When the majority of a particular ISP's traffic is IPv6, their QoS policies will start to favor IPv6, and IPv4 will become the poor man's network. Okay, that's an interesting philosophy. The poor man's network. That's what I'm on. I'm using the poor man's network. I actually don't know if my provider here provides me IPv6. I don't think it does. I think I'm on the poor man's network. But then again, I would have to check, and I know that I disabled IPv6 on my router, so I did that a long time ago. I'm not using a router from my ISP. I'm using my own, and I disabled IPv6 a long time ago, so I don't even know if they hand out IPv6 addresses. I know Comcast does, and I think Verizon does it some places, but I'm on a Verizon network, and I don't have IPv6 here at home. All right, so speaking of IPv6, let me get off the poor man's network and try to configure some IPv6. I think I will probably screw this up. Spectrum does. Okay, yeah, we don't have Spectrum in this area. I think we have a couple of well, at least in my coverage area, it's Comcast or Verizon. You only have 2. But I think in our area, like the wider area of like people that I work with, and you know, they live miles and miles and miles and away. I think everyone has a range of like Cox or Time Warner, Comcast, Verizon. I don't know if there are any others. Optum. I don't know if there are any others, but I think that pretty much covers the large majority of the people in my, you know, within a 20, 30, or 40 mile range. All right, let's try some IPv6. R1, R2, R3, and R4. Okay, so the first thing we want to do is make sure that let's turn off some Wireshark. Close. IPv6 unicast routing. Just going to make sure this is turned on. I got burned by this in a lab long ago where I was sitting around configuring IPv6, and I thought I had everything configured, all the protocols, all the IP addresses and everything, and I forgot to turn on IPv6. And it didn't work for me. I don't know what the issue was. I remember taking ICND 1, studying hardcore for IPv6. Didn't get one question. I'm trying to think. I think I got a handful, maybe 5 questions on IPv6 when I did it before, and there wasn't very much. I like the ones where they say, this is a pretty common question. You'll see it in a lot of practice exams. It'll give you like a list of addresses, and it'll say like identify, which of these is not an IPv6 address, and it'll have like the letter G in it. Because hex ends at F, so it'll have letter G in there. I think I actually got caught with that one once. I just obviously wasn't paying close enough attention, and just trying to hurry through it, and that wasn't good. Definitely pay attention. And I guess I need to come up with like an IP schema for IPv6. So I guess we can start with the tunnel interfaces. And I don't remember if my tunnel interfaces can be link local or have to be global unique. Because I'm wondering, I think one time I was doing a configuration and one of the protocols didn't support, only supported like link local IPv6 address. I don't know, we'll see. So let me do interface tunnel 1, 2, 3, 4. Let's start with that. Let's do IPv6 address, and let me give it 2001, and then we'll call it I don't know, 1. Doing a 64 here. IPv6 address. See, I'm even uncomfortable just typing this, which I've screwed that up. This needs to be 2. I'm even uncomfortable like typing this. I just don't have the muscle memory of typing the IPv6 addresses, so it's definitely worth the good practice, even if I fail. Okay, we got some IPs configured. Now to run IPv6 on a DMVPN tunnel, we need to start specifying IPv6 NHRP. So for this, IPv6 NHRP network ID, and we can call this 1111. Kind of give us something a little different. IPv6 NHRP. NHRP network ID 1111, even though they don't actually have to be the same. Just for stare and compare purposes, I'm going to make them the same. So when I try to troubleshoot this, I know what I'm looking at. How's everyone doing this Sunday? It's a great Sunday to be labbing. It's freezing cold here in the DMV region, at least freezing cold by my standards. It was nice and warm when I was down there with you guys in Orlando. I couldn't believe it was 88 degrees in Orlando, and it was 36 degrees when I got off the airplane to come back home. That was quite a spread of temperatures. And I flew out a night early. Warm in Florida. Yeah, I flew out a night early. I was supposed to fly out Thursday morning from Orlando, and instead I went ahead and called the airline and got the last flight out of Orlando for the night. And it wasn't actually that late. It was about 9:30 at night. So I showed up at home just past midnight on that night. So kind of surprised my family a little bit. It was fun. All right, so, oh, you see what I did? I screwed up this. Look, I've made this mistake. I did IP NHRP. It's IPv6 NHRP network ID 1111, and it's IP NHRP network ID 1234 was my network ID for IPv4. Okay, next up, let's set the next hop server. So IPv6 NHRP next hop server 2001:1/64. Yep, and I think I remember this being a problem. So I can use an IPv4 address as my NBMA. Let me think about that. I think I want to do a full IPv6. Or, I don't know, do I want to try it? Yeah, what the hell, let's try it. NBMA 192.168.1.1. Give it an IPv4 NBMA address. We'll call this sucker multicast. Enter. And you know what I can do? I can paste that sucker all around the board. Here I'm going to do IPv6 map multicast NHRP map multicast dynamic. I don't know why I keep exiting out of the tunnel interface config. Okay, I'm just trying to get sort of a warm in Florida. Shorts and short sleeves. Oh man, it's a dream. I am freezing cold here. Okay, let's see what we have. All right, I have the tunnel interfaces specified. It's going to ride over an IPv4 transport. Do I have to change the tunnel mode to be, no, it's multi-point IPv4 as the transport. So I should be able to carry IPv6 and IPv4 over an IPv4 underlay with this config. So on router 1, let's do end show DMVPN IPv6. Okay. Our peer MBMAs. So I'm the hub. Total peers 3. Oh, this is giving me V4 and V6. Wait a second. Okay, tunnel IPv6 address, IPv6 target network, status up, down time, and cache attribute D for dynamic. That's very cool. Let's see what it is over here. Show DMVPN IPv6. Okay, I see only one attribute is S for static. Very cool. And it's using an IPv4 transport. Man, this is very cool. All right, so let's create, well, I have a loopback interface. Let's add an IPv6 address to the loopback interfaces to be treated as our LAN segment. And let's start including some routing protocols. And we'll do EIGRP, IPv6, give it a try. And so what we're going to do is, I guess, try to pass IPv6 traffic over an IPv4, a DMVPN, an IPv4 underlay. This would be pretty cool. So let's start with router 1, conft interface, loopback 0, IPv6 address, and we need to call this 2001. And let's do 1, 1, 1, 1. Kind of go all the way around the board. Maybe I'll just try it for this one. IPv6 address 2001 11 colon 164. Nope. I want to do 4 4 4. Sure, why not? IPv6 address 2001 3 3 364 interface loopback 0 IPv6 address 2001 colon 2 2 double colon 2. All right, so some static routes would get us across, but that's no fun. And also I need to practice IPv6. So config, so IPv6. See, I always forget about this way to configure things. For the autonomous system number, let's call it 1111. We'll call it the same as our NHRP network ID for our IPv6 network. And what are our options here? All right, what you don't see is the network command. So I tell you what, hang on, do show IP protocols. Okay, do show IPv6 protocols. I see EIGRP here. No interfaces listed. I'm going to see what the defaults here are. So the default is no shut. Distance command is already set. Okay. 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 Do show IP, IPv6. Okay. So I'm always confused about how that works. The different ways to configure the routing protocols. So let's hop on, I guess any of these should be okay. Let's do router, IPv6, router EIGRP 1111. Interface tunnel 1234, IPv6, EIGRP 1111. All right, got an adjacency. Is up, but I didn't see an adjacency down here. IPv6, router EIGRP 1111. Interface tunnel 1234. IPv6 EIGRP 1111. Right, that's a new adjacency. Router 3. I'm under the tunnel interface, so let me. IPv6. I just want to see if activating it on the interface is enough. I guess not. It's not activated here, so IPv6 router EIGRP 1111. Then we should see it bounce here, right? Let me see. Show IPv6 protocols. It says tunnel interface. All right, so this is router 2, 3, and 4. It seems like it's bouncing. Yeah, I think it's bouncing. Show interface tunnel 1, 2, 3, 4. Excuse me. Show IP and HRP. Tunnel 1, 2, 3, 4. Okay, I'm seeing map the multicast traffic. Show run interface tunnel 1, 2, 3, 4. IPv6 map multicast network ID. Can't quite figure out what's bouncing. What's it bouncing? Dual stack Teredo. I thought Teredo was Windows only, right? Oh. All right, why are we bouncing? Show IPv6 interface brief. Okay, tunnel interface. Show IPv6 interface brief. All right, it says the neighbor 2 is up. So it's using the link local as the address. I have encryption on here, so I can't see the payloads. Show IPv6 NHRP multicast. Show IPv6 NHRP multicast. Do show run interface tunnel 1 2 3 4. Trader's a way to tunnel IPv6 traffic over an IPv4 only network. Correct, but I thought that was only for Windows networks, right? I mean, I thought only Windows supported the Teredo tunneling. Is that right? Is it for Mac or Linux or anything else? Like, I didn't think like Cisco routers supported tunneling, right? It's at the host level, I thought. I know one of the things we often have to do when deploying like new workstations and stuff like that is disable Teredo tunneling. You can run Teredo on most any operating system, including Cisco iOS router acting as a client. I didn't know that. Thank you. I probably won't be diving into that today as I'm struggling to get this EIGRP resolved, but what the hell? Okay. Debug IPv6 EIGRP. I don't know if I'll get any more verbose debugging than what we already have, but okay, the multicast traffic is being mapped. I'm just waiting for another error message to pop up, but maybe I'm not seeing it. Show IPv6 EIGRP interface. Got the tunnel. Neighbor. No neighbor. I'm trying to think what would be stopping me from forming an adjacency. There must be something very basic I'm forgetting. I mean, I know I still need to turn off like split horizon and next hop self and all that. What if I like manually configure the link local address? I'm not seeing any adjacencies come here. I wonder. All right, it thinks it has a neighbor. The hub does. It sees the link local addresses. That's fine. And I guess when this hold time expires, uh-oh, one went away. And that was tunnel 4, 3, 4, 3. Tunnel 3, tunnel 4. Let's try this here. Debug. Is that interface passive? Oh man, let me check. Show run. Let me do section router. Section IPv6 router. I got no passive there. Nothing. Nothing. I don't have any passive interfaces. Sorry, you were right about Teredo. I was thinking about Isotap. Show IPv6 protocols will tell us that we're running on our interfaces. Do show IPv6 protocols will show us that we're running on the tunnel interface. Nothing unusual here. I'm wondering if there's like something wrong with the multicast traffic. How about if I do debug IPv6 packet? Don't blow up the router, please. Encapsulation failed. Could not queue for resolution. Wait. IPv6 forward. Encapsulation failed. Destination lookup for turn it off. See what that says. IPv6 forward. SAS on interface tunnel picked source. Okay, so it's picking link local for the multicast of FF02A. Okay. The source, destination, traffic class, protocol 88 is EIGRP, hops 1 originating, encapsulation failed, could not queue for resolution. Destination lookup, local interface. Next hop, what? The destination lookup for is a local interface tunnel. The source is 1111, destination 2222, okay. It says encapsulation failed. could this be like a MTU issue? I mean, timers are the same, right? Yeah, we did check the timers. IPv6 MTU. I'm really just shooting in the dark here. IPv6 MTU. So do show IP protocols. Whoops. Show IPv6 protocols. And should be our timers where active timer 3. I mean, the timers aren't really an issue on EIGRP. But I think we can do show IPv6 EIGRP. I don't think I've ever seen that that layout before. All right, so maybe I can try to get around this by using unicast. By using unicast. Let's try. IPv6 router EIGRP 1111. Neighbor. And here, IPv6 router EIGRP 1111. And neighbor. Okay, and adjacency came up. I see it on both ends. Show IPv6 route. All right, let's see this one. All right, so I have an adjacency up, but I'm not seeing the other one's timeout anymore. So I kind of don't want to go around and do unicast. I want to figure out what's the problem. Show router EIGRP. But what I'm thinking is if I do show IPv6 route, like I don't see the link local in there. And I understand, you know, it probably shouldn't, but because we're peering using the link local, do I need like a route for them? Like, would that be crazy? And like, I think that would be crazy. In fact, I don't think I can put a route in for Yeah, or is it 10? Yeah, I don't think I didn't think that would let me. Okay, so that means that the multicast is failing. Why is the multicast failing? Let's think about what happens. So it's failing to encapsulate. And it's failing to encapsulate when it's trying to send to the multicast address of IPv6 EIGRP. Out the tunnel interface. Maybe there's a bug. Maybe there's not. Maybe I'm just missing something. But what I'm going to try is IPv6 NHRP map multicast, and I want to map it to 192.168.1.1. Do show run interface tunnel 1234. Scared. I don't know what's going on. I didn't see anything. I didn't see anything hit here, so. All right, well, I guess I'll do some unicast, and I'll just have to come back to this. So under router, neighbor, fade 2222, tunnel 1234. So this is almost the exact same sort of configuration style that I did with the IPv4, which okay, we have an adjacency. Yeah, so weird. I don't know why it's not working. Definitely have to take a deeper look at that. But just to try and get the prefixes, I mean, neighbors up. Neighbor F8111, and it's what is it? The egress interface. All right, IPv6 address fade. Okay, and adjacency. Interface tunnel 1234. IPv6 address. IPv6 address. All right, now we should see that. Okay. Oh my gosh. Show IPv6 EIGRP interfaces. Got one interface. Now let's do neighbors. Good. 3s, 4s, and 2s. All right. And then from here, do show IPv6 EIGRP neighbor is 1. And then next we have to include the loopback, I think. So show IPv6 interface brief. We got the loopback there. So interface loopback 0. IPv6 EIGRP 1111. Uh-oh. Router 3 is no good. Show IPv6 interface brief. Do show run section IPv6 router EIGRP 3333 3333. Is it flapping? I guess we'll see. Show IPv6 route. Show run section that sucker is bouncing. I don't have the I don't have an explanation for that. But what I do want to see is our networks there and show IPv6 route EIGRP. All right, I still have split horizon turned on the tunnel interface tunnel 1234 for IPv6. So no IPv6 split horizon EIGRP 1111. Should cause a bounce, right? There we go. Check our routes here. Cool. So again, everything is from an IPv6 perspective is trying to go through the hub or router 1 in this case. So I think we also need to do no IPv6 split horizon EIGRP 1111. Should cause a resync because it needs to update the routing tables with the new next hop. Oh, I did split horizon again. That's why I didn't. Next hop self EIGRP 1111. Okay, new adjacency. And there's the prefixes. All right, very cool. So now we should be able to have some. And what's our next hop? Yeah, the next hop is straight to the router. So show DMVPN IPv6. So what I see is the tunnel interface resolution as well as the link local interface resolution. The link local is dynamic. Okay. And looks like this one is static. So that's the one I configured. Is that right? Because I said the next hop server was that global. Maybe the next hop server needed to be link local. Maybe that's what it needed to be the whole time. Now I'm questioning this. Maybe I'm right. Let's do the test. Let's test it. Always be learning. Do show run interface tunnel 1 2 3 4. I want to change this to the link local. Okay, IPv6 router EIGRP 1111 and take off this static neighbor. No. Here, IPv6 router EIGRP 1111. All right, so I have only 2 static neighbors. So I'm wondering now if having these other static neighbors configured, if that is deactivating multicast, being able to receive. So I'm just going to negate the static neighbor commands. And now I have a new adjacency with router 4. So as long as we have a neighbor configured, a static neighbor configured, it sort of deactivates the multicast for receiving neighbors there. So let's see, whether this bounces or not. This is the first time I've seen the adjacency form. The first time I've seen the adjacency form on the spoke using without the neighbor statements. So I think maybe that was my problem all along. So let's do show run section IPv6 router EIGRP. Let's get rid of this. We'll do no, and then show run interface tunnel 1 2 3 4. Wait a second. Looks like an adjacency came up, but again, I think we're using the wrong one. I'm using the global unique address when I think it wants the link local. So we can just modify that. And I, 100% should have known this ahead of time, but again, I just don't lab up IPv6 very often. It's 12:30. I'm getting hungry. All right, here's the neighbor with the new adjacency. Why this is not coming up. Show run interface tunnel 1, 2, 3, 4. Maybe it's waiting for a timer. Show IPv6 EIGRP. Neighbor. Oh, I have a neighbor. Been up for over a minute. Okay. Let's see this one. Show IPv6 EIGRP neighbor. No neighbor. Show run section IPv6 router. Because I have a static neighbor configured. Let me take it off. Show run interface tunnel 1, 2, 3, 4. And I want to adjust this to use that link local for the next hop server, not the global unique. Why that did not work. Show IPv6 EIGRP neighbors, and off you go. Show IPv6 EIGRP neighbors. There's my 3 neighbors. Very cool, very cool. So it's going to use the link local address for EIGRP. It's going to use the link local address for EIGRP, which I would probably assume if I need to, in a DMVPN environment, if I need to configure the next hop server, you need to know what the link local address is on the other side. So I would assume that means we need to configure it statically, just to be able to have control of what that next hop server is. Or there must be a way to tell EIGRP to use the tunnel interface instead of the link local address. There must be a way. Okay, let's check the routing table, the IPv6 routing table, just to make sure we're in good standing here. Okay, looks like we see the remote networks, show IPv6, EIGR route, EIGRP, and we see the remote networks. Let's see if we can do a ping. Well, that was a failure and slightly embarrassing. And why is it not working? Show DMVPN IPv6. Okay, it's unknown. But router 4 should be sending a resolution request. Incomplete. I'm looking what the I and the X are, which is incomplete and also no socket. So it knows the tunnel address is here, but cannot resolve the next hop. Why the hell not? All right, let's just see if we can ping across to the hub. Okay, we can. And so if I do show DMVPN IPv6, should be good. Show IPv6 and HRP. Okay, this one is the one that's not hitting. All right, how about clear IP and HRP? How about clear IPv6 and HRP? Show IPv6 and HRP. Damn it, it still has this damn thing in here. How do I get rid of that? Clear IPv6 and HRP. This is confusing me. This is the link local. That should be what I have configured. Why does this say NHS and I assume LL is link local? Let's take a look. I'm going to do a search. Taking a look at a Cisco Learning Network link. Hey guys, I realized this is a bit over my head. I was doing a DMVPN setup where spokes connect to the hub with IPv6 NBMA. IPv4 and IPv6 stacks over the tunnel establish OSPF v3 relationships over the tunnel. Someone posting a topology here. Hmm. I'm looking at I used a global unicast address on the DMVPN tunnel interfaces in my topology and changed the tunnel source on the DMVPN tunnel interface from a specific IPv6 address to the source MBMA interface. Hmm. All right, well, this was a pretty good link. I don't think it's exactly what I'm doing, but I'll go ahead and share it anyhow. Some pretty good back and forth. Not exactly what I'm faced with here, but okay, let me get my stuff back in order. Okay, why can't I have spoke to spoke? Ping, let's just try to go to the link local. There we go. Okay. So I'm trying to go from router 4 to router 2. God damn it. It's driving me nuts. I mean, what's the point in putting a tunnel interface in there if you need more information? Okay. And then next I will try show IPv6 route. I will try this 2001. Then I'll check the DMVPN and we'll see what happens. I'm confused. Hmm. When I use the link local as the next hop server, I get an adjacency. That's good. Okay, let's see if I can ping the tunnel interface to the tunnel interface. I can't. That's pretty interesting. But I can ping link local? That is crazy. Hmm. Hmm. I'm just staring at it, trying to think in my mind what could possibly be going on, and I don't have any answers at the moment. I wonder if it has anything to do with being an IPv4 underlay. I don't know. I guess I could try. I don't know. I don't know. I'm getting distracted because I guess I'm a little bit hungry and getting frustrated. Um, so I think I'm gonna go take a break, get something to eat, and I'll be back on to work some more of this lab. I hope. So so I don't know. I'll be back in a while. Let me put like an away message up. Actually, I think what I'm gonna do is I'm gonna stop the stream and and go have a lunch, and then come back and fire up again and see if I can't get this lab to work right. So thank you all for joining me today. Thanks for anyone who's still out there. I really appreciate it. And I'll see you guys a little later this afternoon. Thanks.